Yeah, I want to do that thing. What's the thing? Me? Nike. I thought you wanted to. Nike. Oh,
Yo, what's this?
Not, wait.
Oh, you can push it out.
We should have, like, we should take a picture. We should have, like,
Yo,
Maybe buy one that does that.
never the magnets.
I wanted to keep going and talking.
okay. Sure, you want.
Have a good day.
Where you going, Ozzy?
All in one day.
Congrats.
Sometimes I need you to sign something real quick. It's an introduction, but I don't want to do it.
Oh, Evan?
Yeah, we already did this. I feel like we don't have to do the whole thing anymore.
Maybe you should have to introduce yourself to somebody else. You know Brody?
Nope.
Brody sits next to you. You'll like him.
I forgot my binder.
send a copy to.
Okay, so you see the two handouts, there's a handout for pick up, so there's two baskets on that same table. One says Cal AB handouts, one says Cal BC handouts. So there's the AB handouts, and then they're organized by number. So as long as you know the assignment number, it's right in there. It's just for your binder. I don't need it. All right, good morning, guys. There's two assignments you need to be getting out of your binder. They're listed under Bellwork. One of those assignments is due right now. So number 4 needs to be turned in. Riley's business. Shipman. Alvin. Alvin's not here.
Did you say X's out number 23? Correct.
That was one that you
Mr. Tyler. You want number 3?
yeah, just put it in there with your name on it. I turned in 4 online, still in the If you did online, you don't have to do it in the bathroom.
I'm not trying to get another 50. I got too many of those last year.
Alright guys, quickly. If y'all can't get it to me in the next 30 seconds, it's going to be late. Open your binder, go to number 4, take it out, put it in the basket. Anything other than that, I don't know what you're doing. And I can't take attendance till y'all are
You want me to turn this in and then I can do the rest later? Okay.
We need to turn in number 6 too.
Nope. Anything I want you to turn in, I'll verbalize and it'll be written. So I'll probably ask for it, just not. Okay, Alvin. Okay, let's get started, please. Settle down. All right, so anytime I have you guys turn stuff in, most of the time it'll be under Bellwork. You can see it's kind of tough to turn stuff in once there's a bunch of people trying to do that. So those of you that get here a little bit earlier, you might want to come throw it in the basket before it gets busy and gets harder to do that. But just a suggestion. All right, remember if you didn't do that, or if you lost it, you can still finish it up for half credit as long as I get it before our first big quiz, first big test. And I'll remind you of that late policy when we get there. Okay, I also asked you to get out number 7. So today what we're going to do is we're going to spend about half of our time on assignment 7, something called intermediate value theorem. Where's your seat? Okay, well that's how I take attendance, so don't just move yourself. We're going to take about half of class to talk about intermediate value theorem, and we're going to take about half of class, well, I'm sorry, the first half of class we're going to go over IVT and limits at infinity. So that'll be our 2 new topics, and then the second half of class, roughly, I'll give you time to work on finishing those 2 up. All right, so IVT is one of calculus's big theorems. We have 3 big theorems: IVT, EVT, and MVT. MVT is mean value theorem. That'll come up in a couple weeks. EVT is extreme value theorem. It'll come up in a couple weeks. But for today, IVT, intermediate value theorem, is the one we need to talk about. Now, I'm going to go through the definition here. The definition is kind of wordy, and it sounds more complicated than it really is. So just bear with me for a second. Usually once you see a couple of examples, you get what it's going for. And to be honest, IVT is pretty common sense, I think, but we're just stating it and referencing it mathematically. So with IVT, you're talking about a couple x values. So we're going to box ourselves in between A and B, some generic number A, some generic number B. So there's going to be a point at A. We'll call that f of A. That represents the y value when x is A. And there's going to be a point at B. We'll call that f of B. That represents the y value when x is B. Now, the first condition, and you're going to get sick of me saying this, but this is real important. IVT only works if it's a continuous function. So on Thursday, we'll break down more the definition of what it means to be continuous. We actually have to know the 3-part definition to be continuous for calculus. But for today, it just means that the lines are connected. There's no sudden holes, no sudden asymptotes where it's going to infinity or negative infinity. There's no sudden jumping in the graph. I don't know if this graph zigzags a lot or if it's a perfectly connected line. It's probably something in the middle. So go ahead and connect them and make sure there's no breaks in your graph. Okay, what IVT says is whether f of A is smaller than f of B, or if f of B is bigger than f of A. Either way, it doesn't matter which is which. There will be an f of C value between f of A and f of B. So somewhere between A and B, there's a C, and f of C has to be bigger than one of f of A or f of B and smaller than the other one. Now let's finish the notes and then we'll throw down some numbers and I think it'll make more sense to you. But according to IVT, there is a value C such that f of C is going to equal some number. This changes depending on the question we're doing. So, and C has to be trapped between A and B. Again, it's kind of a weirdly worded theorem, so let's backtrack and say what it's actually saying here. To make this a little bit easier, let's actually make these points just so we have concrete numbers to look at. Let's call this like 1, 9, and let's call this, I don't know, 6, 2. All mean value theorem says is that if it is continuous from 1 to 6, like this is, you are guaranteed to hit all of the y values between these. So if this starts at a y value of 9 and it ends at a y value of 2, do you see how it has to hit every y value at least once? That's all IVT says. If it's continuous and it's not jumping around, it has to smoothly hit all of the y values in between. Now, we don't know if it's hitting the y values a bunch of times, if there's a lot of zigzagging. IVT guarantees that it hits all of these values at least once. All of the values between the starting y value and the ending y value. So I know it hits everything from 2 to 9. So IVT also occurs in the real world. And when you guys came to school today, no matter where you know, if you rode the bus or somebody drove you or if you drove yourself, if you told me your top speed was 60 miles per hour, I don't have to ask you if you were going 50 miles per hour at some point. For you to get to 60, you had to build your speed up, and even if it was just for an instant, I knew you had to go 50 before you could get to 60. It's kind of the same idea there. You've got to hit everything in between. So a lot of the questions are going to look like this. They're going to give us a table and ask things like, what's the minimum number of zeros? What's the fewest number of times y could be 1? Must there be a value when y is 2, etc. Now, I don't think this is a good long-term strategy But at first, what you should do is take an extra 15 seconds and just plot these points. Plot 0, 1, 3, negative 5, 4, 3, 8, 8, 7, and 9, negative 1. We only know 5 instances to this question. But notice in the directions it does say, by the way, this is a continuous function. So I know all of these points are connected. Now again, this could have a lot more zigzagging in this than I expected. You know, it could just do this that nobody ever predicts. And it could be hitting multiple y values tens, dozens, hundreds of times, potentially, if it zigzags enough. But realistically, it's probably just going through and connecting these things, something like this. So until you do a few of these questions, I think you should spend just a minute and make yourself a graph, because you're going to see this makes it a lot easier. So now that I have graphed this, remember 0 just means x-intercept, where y is 0. So how many times do you have to have x-intercepts for this function? 3 times. It has to cross 1, 2, 3. Now, it could be more. That's why it says minimum. If it's zigzagging, it could be more. But the minimum is 3. It went from above the x-axis to below, so it had to cross once. It went from below to above, so it had to cross once. And then it went from above to below, so it had to cross another time. It has to cross 3 times based on those values. Okay, pay attention to these because these change sometimes. It's not always the whole table. This one just says 4 to 9. So 1, 2, 3, 4. 4 to 9. Is there any times where y is 1?
Yes.
Right here, right? So there's at least 1 time. More if it zigzags, but at least 1. That's the fewest number of times. Now again, notice that picture gives you a visual. You can just see here's where y equals 1 is. From 4 to 9, it's only hitting in one place. That's where I think the picture is going to help you. Okay, this one I want you to think about. From 0 to 4, does there have to be a y value of 2? If it helps, sketch it in. From 0 to 4, does it have to hit our graph at least once? Right here, yes. If this was at, I don't know what that is, 3, 4, this is 3, 4, and this was, I'm sorry, this was 4, 3. If this is 4, 3, and this is 3, negative 5, it's hitting all the y values from negative 5 to 3, at least once. So this is the part that we're going to have to do the most work for here. So the answer is yes, but we need to make some good habits here for our explain. So it's still kind of early to talk about this, but the brief explanation is most of our quizzes and tests will be multiple choice and FRQ, just like your AP exam will be. Most of the time, the multiple choice questions are more straightforward. FRQs are the ones that students tend to think are difficult. But a lot of what tends to be difficult is knowing what's expected for the explanations. Like you might get a point for saying yes or no, but sometimes you have to have that and the correct explanation. So what we need to do, make sure that you copy this down well, because I want you to be consistent with this as you move along and practice the rest of these. But you need to say something about how f is continuous. If you don't state that f is continuous, then you better not be referring to IVT. IVT only works if it's continuous. You would need to say something like the starting y value was 1 and the ending n value was 3. F of 0, f of 4. It starts at a y value of 1, ends at a y value of 3. So IVT guarantees, is that how you spell guarantees?
Yeah.
Okay, good. So IVT guarantees we get y values between 1 and 3. When x is between 0 and 4, and we need to say that 2 is between 1 and 3. So, a couple things here. I need to say is continuous so that I can talk about IVT. I need to state the y value at the beginning and end. Tell what IVT says. It means I'm going to hit all the values between 1 and 3. But it's only going to hit the values between 1 and 3 during this time. So if you don't say during 0 to 4, that's not always true if you're talking about 0 to 3. So it matters if you talk about when it's true. Also, I know this is silly, but the reason the answer was yes is because 2 is between 1 and 3. You need to state that. 2 is between 1 and 3. I know that that's obvious in your head, but when you're doing it on an FRQ and you're trying to show your work and show the full explanation, you need to make a habit out of that. So on the next page, I think we might see one more of these together, but I will do the same thing. I'll say this continuous. I'll find the start and end y value. I'll talk about how IVT guarantees we get all the y values between those during the x values for that question, and our answer, our y value will be between those two y values. We really need all of that for a full explanation. Okay, so back to our graph slash table. From 4 to 8, could there be a value where y is negative 2? From 4, could there be a y value of negative 2?
No.
Yes.
That sounds 50-50. Why do you think yes?
Because it doesn't have to follow. We don't know where the line goes.
Right, remember we only know exactly 5 instances. I have no idea what's going on between 0 and 3. Between 0 and, well, this question's about 4 to 8. But between 4 and 8, I have no idea. It may go straight from 3 to 7 in a straight line. It may zigzag. It may do this. It may go down there where y could be negative 2. So IVT tells us what we can guarantee, but other values still could happen. So could there be? Yes, but intermediate value theorem does not guarantee it. So maybe, but we don't know for sure. Anything could be happening between those points though. Okay, and then one more like this, and then I'll go through one more set with you and show you a slightly different approach. That might be easier for you. Okay, so from -1 to 5, does this function ever have a value of 8? And explain. Well, honestly, I have no idea till I try. I know f of -1 would be the starting y value, and that is 3. I know f of 5 would be the ending y value, which would be 21. So what do you think? Does it ever equal 8? Okay, so that's understanding it hits all the values between 3 and 21. You understand IVT. As I said, it's not really that complicated of a theorem. Probably what's hard though is this explain. You guys have to train yourself to spit out the right answers here. This is continuous. F is a continuous function. Polynomials are always continuous. Now that I've said it's continuous, I can talk about IVT. Bless you. And by the way, you're feel free to use these abbreviations. Even on the AP exam, they don't expect you to write out intermediate value theorem. You can just do IVT, and that's perfectly acceptable. So IVT is going to guarantee that we get values between 3 and 21 when x is between -1 and 5, and maybe the most obvious part, but what else should I say about my explanation?
8 is between 3 and 21.
Great. So the reason why y'all said yes is because it's between 3 and 21, and as silly as that sounds to put it down, without saying that, you're not really saying, okay, so it's 3 here and 21 there. IVT says it is 8, but why does IVT says it's 8? It's because it's trapped between those two. So that'll get easier as you do it a few times, but just lean on those first couple of examples to make sure you're getting all the parts. Continuous, IVT guarantees it's this y value to this y value during this time, and this value is between that and that. Okay, I'd like to do one more example for you, and I just want to show you a different approach other than this. Again, I don't think there's anything wrong with this. You can see it only took me about 15 seconds and it made the questions easier. But as you go on, you may not want to make this. You might just want to look at the table. I think the table is fine a lot of times. So that's what I'm going to look at on the next page. I'm going to do this one more set with you here, but I'm only going to look at the table. Okay, so from -5 to 1, make sure you're looking at the right values here. We're not using the whole table. In fact, on a test, if this was the question, I would suggest you kind of just box it in to help focus on what you're supposed to be looking at. From -5 to 1, do we have to get a y value of 30? That is correct, yes. Why is because he's continuous. That's why they put that in the direction. And because he's continuous, IVT is going to guarantee that we get y values from 7 to 40 when x is during this time, and 30 is obviously between 7 and 40. If it has a y value of 7 here, a y value of 40, and it's continuous, it's got to hit 30 sometime. It might hit 30 a bunch of times, but IVT tells us for sure it's going to hit it at least once. Can't talk about this unless you say it's continuous. You can't really talk about these values unless you're talking about when, because if you change the when, then it would change the values. And the reason why you're saying yes is because 30 is between 7 and 40. Just write it on your paper though. All right, maybe somebody I've not heard from today, from 3 to 8. So if I'm just looking at this, could there be a value where y is 100? Yes.
Oh, yep, that's right.
There could be. IVT doesn't guarantee it. It only guarantees values between -21 and 75. But it could be going up to 100 and coming back down. So yes, but IVT does not guarantee it. That word could versus must completely changes our work and our justification. Okay, for -5 to 14, -5 to 14, it wants to know what's the minimum number of zeros. Now again, you could just plot these 5 points on a fake graph and that might help you. But here's what also you can do. If I just start from here to here, does this have to cross the x-axis? Doesn't have to. Above the x-axis, it doesn't have to cross. From 40 to 21, does it have to cross the x-axis? From y value of 21 to a y value of 75, does that have to cross the x-axis? From 75 to negative 100, does that have to cross? Okay, and so what's happening is you're starting above or below the x-axis and then switching to the other side. So there is one time it has to cross the x-axis. Notice you don't have to have a graph to see that if you're looking at those table values. Above, still above, still above, still above, below. It definitely crosses the x-axis one time for sure. Okay, from 1 to 14, I think I missed this question in second period today because I looked at the whole table and not just 1 through 14. What's the fewest possible number of times y could be 20? Well, from y equals 40 to y equals 21, there's no guarantee that it was ever 20 there. From 21 to 75, doesn't necessarily ever hit 20. 75 to negative 100 does. It has to cross 20 at least once there. And then finally from 1 to 8, make sure you're looking at the right part of the table. What's the fewest number of times y would be 7? Well, 40 to 21 doesn't ever have to cross 7. 21 to 75 doesn't have to cross 7. So I guess I would go with 0 there. Does that sound right?
But could it happen though, theoretically? Like you said, it can be something or not.
Yes. If it said, could there be a time y is 7, you would have to say yes.
Could there be a what? 7?
If the question was, could there be a time when y equals 7, you would need to say yes. But this is asking for the fewest possible numbers. Looking at these values, it could never happen.
Oh, okay.
Because it's above 7, still above 7, still above 7. It might just be above 7 the whole time. I can't promise that it's ever 7. So the wording is a little bit, you got to be a little careful about. Big difference between must and may. Fewest possible, minimum number. The explain is the part that I'm most concerned about. Again, if you just use one of these as a template, when you need to do that, make sure that you get all the stuff. Forcing yourself to do that will make it easier to remember what to do if you see it on a test. Okay, we are going to put this one aside for a few minutes, and again, after we go over the next set of notes, I will ask you to come back to this and practice some of these on your own. But is there any quick, immediate questions you know you'd like to ask about IVT? Anything that doesn't make sense to you on it yet? Okay, then let's go ahead and talk about the notes for number 8. I also had you guys pick up assignment 9 on your way in. We didn't have time to get to that yesterday, so just put number 9 in your binder. It won't be your homework or classwork, but we'll look at it some on Thursday. Okay, this one is about limits at infinity / horizontal asymptotes, because they're basically the same thing. Now, what I mean by limits at infinity is I'm going to be asking things like, what happens as x goes to infinity or negative infinity? That's what it means by limits at infinity or infinite limits. But when you're talking about the very far right of the graph or very far left of the graph, if you're talking about a rational function, that's 100% the same thing as a horizontal asymptote. So the first off, we need to remember the 3 rules for horizontal asymptotes, because that's going to be our work for some of these questions. And again, I'm not too crazy about this set of notes here, but maybe it'll remind us. But this is the part that's also on the ACT. So if y'all are still taking the ACT trying to bump your score up, you need to make sure you remember this. Okay, so if you just have a great big fraction, a rational function, that's when you can apply these horizontal asymptote rules. if your denominator is growing at a rate faster than your numerator, if the denominator grows faster than your numerator, then your whole fraction is going to go to 0. When the numerator and denominator grow equally fast, so they have the same degree basically, you're going to put leading coefficient over leading coefficient. If you don't remember what this stuff means, we'll see it in a few examples in a moment. Just hang tight. And then the only other possibility, either the denominator could grow faster, they could grow at the same rate, or the numerator could grow faster. So third possibility, if the numerator grows faster than your denominator, then this fraction just keeps getting bigger or smaller. It depends on the sign. So it's going to infinity or negative infinity, or just say does not exist. Remember, we talked about those are interchangeable. The problem is, if you say infinity and the answer is negative infinity, now you miss the question. If you say infinity or if you say does not exist and the answer is infinity or negative infinity, you're fine.
What would have to happen for it to do not exist?
Anytime the numerator grows faster than the denominator.
So that does not exist.
So that means if I graph this, that means well, this graph would look like this. Sometimes it goes to infinity. Sometimes it goes to negative infinity. It just depends on the direction and the function and all that kind of stuff. That's why it's safer to just say does not exist, and then you don't have to worry about it. Okay, so we need to put some thought into which the numerator or the denominator growing faster. So at first I wasn't really sure why they put this table here. Again, these are not my notes that I made up. But then I realized that I think what they're doing is they're showing you an example of if these were your numerator denominators of questions and you needed to compare them, one strategy that you could use is you could plug 1 into them to get some values, and then you could plug 10 into those to see how they're growing, and then maybe plug 100 into those to see how they're growing. And then once you have that information in front of you, which one of these is growing the slowest?
6,900.
Natural log of x. It's the slowest. So this is 7th fastest. Which one of these is growing the fastest?
1.6 times 10 to the 6th.
Well, I'm talking about, I want to know the function, not the values at 10 or 100. Okay, so next up would be these exponential functions. Exponential functions grow very quickly. So this would be the fastest because it's got the biggest base. This would be the next fastest because it has the next biggest base, and then 2 to the x. Exponential functions are one of the fastest growing type of functions that there are. There are a few that are faster. Do y'all know what factorials are? The like exclamation looking sign? Okay. If you take BC next year, you have to learn that. So, but factorials grow faster than exponentials. Okay, then after that, these polynomials. So x to the 10th versus x squared. You can see they kind of start off the same, but plugging in 10, you can quickly see that this one grows faster than this one, it grows faster than this one. So worst case, if you're not sure if a numerator or denominator grows faster, maybe plug in 1 into each of those, plug in 10 into each of them, and then you can just see which one's growing faster, kind of like they did on the table there. Okay, so back to the horizontal asymptote rules that we were using up here. They're wanting us to apply these on 4 through 7, and then 8 or 9, a little bit of a trick question. But so these are rational functions. Again, rational function just means you've got a great big fraction. And if you want to know the horizontal asymptote of a rational function, you just need to compare the degree of the numerator to the degree of the denominator and know those 3 rules. So question 4, the degree of the numerator is bigger than the degree of the denominator, which means the answer to this is either infinity or negative infinity, one or the other. If you want to put some thought into it so that you can figure out which one it is, that's great. But what's a safer answer than picking infinity or negative infinity? Right. Same thing, and that's like covering your bases. I don't mind if you say infinity because infinity is the answer, but if you say negative infinity, it's wrong. Just say does not exist and you cover your bases. All right, number 5, the degrees are equal. So the horizontal asymptote will come from leading coefficient over leading coefficient. Y equals 1/3. Now, even though we don't have to answer it this way yet, this is the connection that you're going to be making between this algebra topic and the calculus topic. If this question wasn't what's the horizontal asymptote, but instead was what's the limit as x approaches infinity or the limit as x approaches negative infinity, that's what a horizontal asymptote is. A horizontal asymptote is the number that it approaches. So I'll draw a picture to show what I mean here. If you had a horizontal asymptote at y equals 4, what we're saying by that is as x goes to infinity, y gets closer to 4, and as x goes to negative infinity, y gets closer to 4. That's why those rules are carrying over. So, degree of the numerator is bigger, degrees are equal, or the third and only other possibility for rational functions, the degree of the denominator is bigger. So, what do we get for horizontal asymptote when the degree of the denominator is bigger? 0, which in calculus means that if I asked you what's the limit as this approaches infinity, you would say 0, and or if I asked what's the limit as x approaches negative infinity, you would say 0. That's what a horizontal asymptote tells you, the end behavior of the graph. So there's, again, notice how all of these are fractions. They're all rational functions. So those are the 3 possibilities that will come up for those question types. Okay. Question 7 is trying to be a little bit trickier. So you might glance at number 7 and say that the degree of the numerator is 1 and the degree of the denominator is 1. So maybe you do leading coefficient over leading coefficient, and you do that, and that's not correct. What's the real degree of the numerator? Very good. So you don't have to actually FOIL this mess out, but you need to at least visualize that x times x would be x squared. Then you would get some x's that I honestly could care less about, and I'm going to have a constant that I could care less about. That stuff is not going to impact your horizontal asymptote when x gets really big or really small. It's only the biggest stuff that matters. Okay, what's the degree of the denominator going to be? What's the coefficient of x squared? Very good, 16. So if you have to, go ahead and FOIL it out. It's not going to hurt you, but 4x minus 3 times 4x minus 3 is going to give me 16x squared plus some x's plus a constant, and I don't even really care about those because all I care about is this. The degrees are equal, so the horizontal asymptote will be what? 1 over 16, which means in calculus class, if you see this, what's the limit as x approaches infinity of that function, your answer would be 1/16, or the left side of the graph would also be 1/16. So be careful. It's not necessarily the numbers you see in front of you. It's if it was all multiplied in descending order and all of that kind of stuff. Okay, so to me, 4, 5, 6, and 7 all kind of go together. Is there any questions you guys would like to ask about any of those? Okay, 8 and 9 are also kind of a little twist to the questions, and they're a little bit trickier. So these are rational functions as well. I could tell you the degree of the denominators are 1 and 2. if we just do both of these at the same time. But what do you think the degree of this numerator is? Is it 2? Okay, good. So it's the square root of this stuff. Now the square root of all of this, I have no idea what that's going to be. But all I really care about is the square root of the biggest part, which would be 2x. Plus there's some other stuff that's not going to matter. So if you think about that square root, then you can see that these degrees are equal, which means that the limit as x approaches negative infinity and positive infinity of y, you're going to be tempted to say it's 2 over 3, and one of these is correct and one of these is off a little bit. Does anybody have any idea why one of these might be different? Okay, it's going to be this one is actually negative. So look what happens when you try to plug this in. If I plug in a negative infinity into the denominator, do you see how this makes the denominator go to a negative number? Okay. What about the numerator? Can the numerator be negative? Can you take the square root of something and get a negative number? No. So this is always positive, and if you plug a negative into this, this is negative. A positive over a negative is negative. That's not a problem here, because if you plug in positive infinity, the numerator will always be positive, because there's nothing you can take the square root of to get a negative number. And if I plug a positive number into the denominator, it will always be positive. Positive over positive is positive. So that one's trying to be a little bit tricky. Okay, on question 9, do the same thing. I really only care about this part of it, the biggest part, and the square root of this is basically 2x squared. That's not really how square roots work, but the biggest part that I care about will be. Since the degrees are equal, that means the horizontal asymptote would be what over what? Okay. And then let's just be careful about the signs, because one of them could be negative, like this last question. Okay, the numerator, is the numerator going to be positive and negative, just negative, or just positive?
Just positive.
Very good, just positive. You can't get a negative result by taking the square root of something. If I plug in negative infinity to the denominator or positive infinity, is the denominator going to be positive or negative? Okay, how do you know that so fast? Right, if you square anything, whether it's a negative or a positive, it becomes positive. So both of these are positive in this question. Top has to be positive because you can only get a positive number from a square root, and the bottom had to be positive because you were squaring the negative number. I guess it wouldn't be positive if x was 0, but we're talking about x really big or really small. Okay, so all of those questions, what was it, 4 through 9, I was applying those horizontal asymptote rules we wrote at the top. There's a few other questions that will come up, though, that horizontal asymptotes don't work on, and that would be a question like this one. This is not a rational function. This is not a big fraction. This is not a big fraction. I can't compare degrees of numerator to denominator if it's not a big fraction. So for these questions, you will have to do direct substitution, and then you've got to put some thought into where these functions are going, what's occurring with these values. So right here, this fraction, if the numerator is growing, well, the numerator is not even growing, but if the numerator is growing slower than the denominator, what does that tell me about this fraction? Good. It's going to 0. And if this is, remember, e is a number, not a variable. If this is e and the denominator or the exponent's going to 0, what is all of this going towards? because anything to the 0 power is 1. So your answer comes from negative 4 times 1. You just have to direct substitute in the infinity. Think about what this goes to. Think about what this goes to. Think about what this goes to. Same thing for 11. I did direct substitution. Now, if you were in my pre-calc class, you might know exactly what this is equal to because I asked you to memorize that at one point. I think that makes these a little bit easier. But you could also do this fraction rule. A negative exponent in the numerator is the same thing as a positive exponent in the denominator. We're going to use this a lot in about a month because negative exponents are considered unsimplified. Okay, so if I have a number and the exponent just keeps getting bigger, what does this go towards? Okay, and then in a fraction, if your denominator is growing faster than your numerator, then your fraction heads to 0. Okay, so direct substitution, and then you have to think about how that's playing out. Okay, I wasn't going to do 12 through 15 with you, but these came up quite a bit in second period, so let's just go ahead and do these for notes as well, and then I'll give you some time to work on these two handouts. So technically, question 12 is a rational function. It's a fraction. But sine is not a polynomial. I want to say polygon. Polynomial. So this doesn't really have a degree. This degree is 1. So you can't just compare the degree of the numerator to the degree of the denominator. So if you can't do that, you need to just plug it in and try to think about what's happening. Okay, what kind of values do you get for sine? Can sine be 5? Can sine be 10?
Between 0 and 0. Negative 1 and
Okay, that helps if you remember what the sine graph looks like. It goes up to 1, down to negative 1. So this numerator, even though it's not still, it's oscillating back and forth, it's basically not growing because it's stuck between these two integers. The denominator, on the other hand, is growing infinitely big. So when your denominator is growing faster than your numerator, your fraction is going to 0. I guess you could make an argument for it maybe being positive over a negative, which would be negative 0, but of course, negative 0 is the same thing as 0, so it doesn't really matter either way. So direct substitution, realize the numerator is not growing as fast as the denominator, so your fraction's heading to 0. On 13, if we do direct substitution here, we get negative 3 times the cosine of infinity. So what is the cosine as your x value just keeps getting bigger? Oh, my bad. I messed this up. I should have plugged infinity in for x. So 1 over infinity is 0. The cosine of 0 is a unit circle question. 1. So your answer comes from negative 3 times 1. I was thinking something else there. Okay, 14. If I try to plug infinity into this, sine of infinity, well, again, if you think about the sine graph, sine and cosine graphs also show up on the ACT, by the way. I know it's been a while since you guys have looked at those, but the further I go to the right, this thing just keeps bouncing back and forth between 1 and negative 1. The further I go to the right, the more it just keeps bouncing back and forth. So it never heads towards a specific y value, so that would be does not exist. And this one, number 15, if I plug in infinity, what do you think that's going to go to?
does not exist.
Okay, that's true. It does not exist. I would say that this probably goes to infinity, right? 5 times a number that keeps getting bigger, this just goes to infinity. This oscillates between -1 and 1, so I guess that's going to change the sign a little bit, but basically if this just keeps getting bigger, this whole thing keeps getting bigger. But you don't need to say infinity, just take the safe route and say does not exist. That covers your basis. Okay, I know that was pretty quick for those four. Is there anything about 12 through 15 you want to clear up? Okay, then I need you guys to get some practice under your belt so you can see what's sticking and what's not sticking. So, the rest of the class, I'm going to ask that you work on assignment 7 and 8. I'm going to ask that you do assignment 7 first. That way, if and when you get the questions, it should be ones that other people have also looked at. So, I'm only going to take questions from number 7 for a little while. And you should have time to finish 7 and get your questions answered on 7 while you're in here. Ideally, I'd like you to finish assignment 7 and assignment 8 in class so that you have no homework. But if you don't get to some of it, then what you don't get to will be your homework. So, yeah.
On number 8 on 7. Is that okay that uses in between -5? Oh wait, I was thinking about it.
Gotta do 20 minutes. Yes or no is just no. And if your answer is no, you just say that IDP doesn't guarantee it. That's all you have to say for now. It's the yes that's the thing. You got to say it's continuous. IDP says it hits all of these values. This value is between those values. You have to be pretty comprehensive for a yes. But a no, just say IDP doesn't guarantee it.
Also, for both of these worksheets, now they're not my answers, but I did share the solutions on our class website. So at some point, it is important that you check your answers. If you're just doing this and you're missing every third question and you never know that you're missing every third question, then that's obviously a problem. So you're welcome to either check your answers as homework or check your answers as you finish these, but I would also encourage you to check your answers as you work on these. Maybe work a section, check it online, make sure it's right before you keep going. I don't want you to have to go back and redo a lot, but if you did it wrong, then obviously you need to go back and retry it. So let me grade these homeworks for a couple minutes so I can get these back to you today. And I will be letting you ask questions, so if you get hard stuck on something, just move on and be ready to ask about it. select on this one, it doesn't say like could or must. So like, could I say like it could, but IBT doesn't guarantee it?
Yeah, that's fine.
Okay. And then if it does, if it will for sure, I can just say IBT guarantees it. Cause like this one it would.
Yeah.
Okay.
But if it's yes, you gotta say it guarantees it because it's continuous, because it's between these two values. Yeah.
So like if it does for sure, then I have to do the all bit.
Yeah. The yes is the pain. The no, just say IBT doesn't guarantee it,
Okay.
but it could. It's just trying to separate these.
Okay, so just looking at assignment 7, intermediate value theorem. Just taking questions on those right now. I want to make sure we get all of those answered for sure. And I know you're not finished with it, but is there anything from assignment 7 that I could go over to help? Number 20? Yes, I will. Okay. And all of my classes have asked about number 20. As I've said in the past, you guys have some options here. I guess my preference would be that you probably jump to this point so that you can catch it. But I also try to clip these videos, individual videos, to be on the website. So I guess you could watch it later that way, or I guess you could pull it up on our class recording. It's just a little harder to find. But I don't normally use some of these notes at the beginning of the year like I have this year. But one thing I really like about these is I like this test prep that they give to you. These are real AP level questions, which take a long time for most students to get comfortable with. But it's good for you guys to see them, because this is what we have to practice to get better at throughout the year. And what tends to happen, it's not like IVT just magically gets harder all of a sudden because you're doing an AP level question. But they tend to put little twists on the questions that really test to see if you know what you're doing or not. So unfortunately, I can't just give you a worksheet with 50 practice problems where I say, if you can do this worksheet and this worksheet and this worksheet and this worksheet, that's everything that you're going to see on the AP exam. They're going to put IVT on the AP exam, but how they ask it, you know, it might be a table with some number K thrown in there. It might be a function where you've got function F and function G. They like to put little twists on there to really test to see if you know what you're doing. Okay, so all that being said, number 20, this is a continuous function, so I know that means IVT is fair game. I know f of 1 is 7, f of 7 is 1, and then there's some function g that is this. G is f of x minus f. Explain why there must be a value c between 1 and 7 such that g of c equals 0. Well, let's find the endpoints. We know IVT is talking about the endpoints. So I need to know the y value when g is 1 and the y value when g is 7. Well, if I plug that into g, if I plug 1 into g, that's the same thing as f of 1 minus 1. If I plug 7 into g, that's f of 7 minus 7. That's kind of an unusual way to go about it, but again, this is how they're keeping you on your toes. F of 1, they put up here, so it is 6, and f of 7 they put up here. Wait, that doesn't sound right.
Minus 7. F of 7 minus 7.
Yeah, you said f of 7 minus 7.
Oh, okay.
F of 7 minus 7.
Right now. So negative 6. So now it starts to look like the other questions. It's continuous. It's going to hit all the y values between 6 and negative 6. So this isn't even a yes or no question. They're saying yes, but they want you to explain why this will be 0 somewhere. So I would say, I don't know, g is continuous. That means I can talk about IVT. IVT guarantees y values between 6 and negative 6 during this time when x, or I guess c, is between 1 and 7. And I need one more thing. What else do I need to really show why this is true?
Zeros between 6 and negatives.
Right. So if it was yes or no, you would say yes because 0 is between those two values, and you're justified. You need to say that. I mean, you can do it in a sentence if you want to, but at the very least do a little inequality there. So now that you see the question, you can see it's still IVT. You're still talking about the y values between the starting y value and the ending y value. But this in red, this is how they put a little twist on the question to try to throw you off a little bit. And, you know, if you kind of know IVT, but you're also kind of winging it, as soon as you throw a little extra bump on the question like that, that usually throws a lot of people off. So. Okay, so that's been a very popular question yesterday and today. Does anybody have anything specific about it before I go elsewhere? I can put one like this on the test and you'll be happy to see it. You should be happy to see it if we've already practiced it. But. Okay, any other questions from assignment 7 that you have ready to go? Okay, let me pass these papers out. There's also 3 no-name papers today, so let me pass out the ones that I have, and then if you don't get yours back, you might need to come check these out and see if they're yours. Obviously, I didn't give you points if you didn't have a name on it, because I don't know whose it goes to, so just wait and see if you get yours back first.
It's just saying there's at least 3.
Yeah.
You know there's 3?
No.
Then you shouldn't pick that. I think the real one is one of these 2 people. Just because you can see 2 of them doesn't mean that there couldn't be more. So you shouldn't say there's exactly 2, you should just say there's another one. She graduated here like 7, 8 years ago. I didn't have her as a student. But I remember her.
And okay, so first I need to give you a chance. You still get full credit on these, but again, if you did not get your homework paper back, it's because you didn't put your name on it. I got 3 with no names. So, who turned in a paper but did not get one back?
Put your name on it.
Anybody else? There's one more.
Give them the button post.
She has it right now. So as soon as she's back. Okay, no one's claiming this one. Okay, anytime I have no name papers like this that I can't find the owner to, I put them in over here. This bottom tray here has says no names. So if you change your mind and you think it might be yours, you might kind of look at it. It's in the bottom. Yeah. And it'll stay there all year, I guess, until somebody claims it.
Mr. Council,
Yeah.
can I borrow a calculator for the 2 questions on here?
Yes. Yeah. If y'all need to borrow a calculator while you're in class, you're always welcome to these. If you have a good idea that you'll need a calculator, just try to grab it at the start of class and put it back at the end of class, but you don't need to ask for permission. Okay, I want to offer one more time. Just on assignment 7, I want to make sure that all those questions are answered. Is there anything from assignment 7 you'd like some help on? Yeah. Number 17. Okay, if g of x is 1 over x, will g of x ever equal -1 from x equals 2 to x equals 5? I don't know. I would just have to plug in 2 into this to see the starting y value. Then plug in 5 into this to see the ending y value. So is -1 guaranteed to be the y value on that? Okay. So will it equal this? I would say, I guess you could say maybe, but IBT doesn't guarantee it. It only guarantees answers between 1/2 and 1/5. That's what I would put. Okay, others from assignment 7? Okay, I know a lot of you guys have moved on to assignment 8. And I don't expect you to find all of the questions you need to ask about. Angel, to pass this back. But has anybody found anything from assignment 8 that you would like me to help with? Those of you that have moved on to that one.
Number 11.
Number
Page 1.
Is it this one? Okay, so as x gets really big, we're trying to figure out what's going on with this. Now, this part of it is kind of hard to see, especially since we can't compare degrees. This is degree 7, But this is not a polynomial, so we can't really think of it as a degree. But which one of these two grows faster? Okay. If you didn't know that x to the 4th grows faster than x to the 7th, you could maybe do what we did on the front page with that table. Like just plug in 1 for x and then maybe plug in 10 for x, and you can kind of visualize which one's getting faster. So if your denominator is growing faster than your numerator, what does this fraction go towards? Okay. And then there's no x here, so this is a constant. This is always minus 5. So your answer comes from 0 minus 5, which would be negative 5. Okay, others from worksheet 8. Okay, in a couple minutes here, I will give you one last chance for questions from assignment 7. Again, I will not take questions on assignment 7 next class because I asked you to do that one first. So if you need any help with it, you should have gotten to it and asked about it while you're in here or when I ask in the next few minutes. Assignment 8, some of you won't finish, so some of you will find questions on number 8, assignment 8, outside of class, so I will give you a chance to ask questions about number 8 before I have you turn that one in. But number 7, you should have correct and completed. Number 8, and you just need to try them all. I would assume that's a typo. Yeah, they should be consistent there. Or assume that would be, yeah.
Is this plus 30? On that space?
Yeah, it's going to be 3 bigger. So whatever you get from the left, like if you think that this goes to 7, then your answer would be 10. You're just adding 3 to whatever it is.
Mine was around the no names, but I did turn it on online also. But
Oh, okay. I didn't think to check them online.
thank you.
How has the no cell phones been going? Is it easier than you thought it would be or harder?
Pretty easy. It's not too much of a change.
Weren't you the one with your phone out last class?
I mean, I was checking answers before.
Checking what?
Answers and stuff. But yeah. I mean,
Sounds unlikely.
I think it's helpful to not,
To not have it?
that easy, yeah. So you don't have that distraction.
Yeah. I may have said this already, but I did see some statistics that schools that have done this, after a couple weeks, students actually prefer it, so. I mean, everyone feels different. You may not feel that way, but. Okay. One more chance. Anything from assignment 7 that it would help if I went over with you? Okay, let me make sure you know where you need to be next class. We've got about 6 minutes to go here, and I have another puzzle for you if you want to give it a shot. But first, so a couple things actually. First is you need to make sure that you are completed with 7. And you should feel very good about that one because I gave you several opportunities to ask questions. Number 8, you need to try all of the questions, check your answers online, But if you find a few that you need help with, I will give you a chance to ask about those on Thursday. So 7 should be ready to go, ready to turn in. 8 should be ready to go, except for the ones that you can't figure out on your own. But you should have those ready to go. That's under homework, so if you glance at agenda while you're outside of class, then you can figure that out. All right, secondly, what is this, the daily meme today? Do y'all understand that one? Okay, somebody explain it to us. Yeah, what do you think?
On the top one,
Uh-huh.
degree is greater, so it goes to infinity.
All right, so the answer to this is infinity. Okay.
Yeah, and that's just like the 8 turns sideways, so it's like 5.
Everybody agreed that the answer to this is infinity? Well, the person looking at it, instead of this being infinity, they thought it was a sideways 8. So here they did a sideways 5. That's the joke part of it.
Figured out that one.
Huh?
That was good. I liked it.
You know I shared this one with your class last year too. Okay, and then if you like puzzles, so I did the clock puzzle with y'all, is that correct? Did anybody look up the answer? Watch the video on the answer?
I figured it out.
What do you think it was?
22.
It is 22. So there's a link on Google Classroom if you're interested in doing that. Did you do this one? How many squares are on a chessboard? I'm guessing no. Okay. So you got a couple minutes here, so you can keep working on your homework if you want to. If you want to put some thought into this one, I assume you're going to just make an estimated guess. But if you think about it strategically, there is a mathematical approach to help you get the exact answer pretty quickly. But I will let you share and see if anyone can figure it out in the last couple of minutes, or if anybody can even get close.
Do you mean like how many squares can you make?
Yeah, how many squares are on the chessboard? 64? Why do you think 64? Huh? One? Yeah, it's more than one. Where are they getting 64 from? Okay, 8 by 8. There's 64 of these individual ones, right? But isn't this also a square? Isn't this whole thing also a square? All of those are squares. All of those go towards the final answer. 64 is too low.
Is it? $4,096.
4,096 is way high. Yeah. 8 to the 8th power sounds way high. 8 to the 8th power is 1,677,000. Actually, never mind. 16 million. Way too high. Any other guesses?
Like each little square could be reused for like another square, right?
Yeah.
So like if I do like a square with 4, I can include 2 from the previous square onto the next square forward.
Yeah.
Okay.
128.
128 is the closest we've had so far, but that's not it.
36.
136 is not it. Is it what? Nope. More than 100. What do you think? 500? 512? It's too big. Okay, if you're interested in a quick mathematical approach to that to get the answer, I've shared that with you on Google Classroom. Obviously, that's completely optional, just for fun. But the answer was 204. There's 64 individual ones, and then if you count up the number of 2x2s, plus the number of 3x3s, plus the number of 4x4s, you end up with 204. Have a good day.